hit record for today's lesson. All right, so today's lesson, we are talking about 4 different types of sampling. All right, 4 different methods on how to take a random sample and hopefully how to do it well. Okay, so your first type of sampling, let me start with an example. Let's say our school, San Marino High School, we have about 1,200 people, but just to simplify it, we're just gonna round it up to 2,000. Let's say we want to survey 100 of our students about the current cell phone policy. All right, so in order to get a random sample of 100 students out of the 2,000, we put each person's name, like every single one of your names, on a slip of paper. All right, the entire student body, throw it in a large container, mix it up, and then randomly draw 100 of those slips of paper. And then we look at those names, and that is our sample. Okay. This example is what is known as simple random sample. All right, this is an example of a simple random sample, also known as an SRS. An SRS. Now, a simple random sample definition is that it's a sample in which size n, it can be 100 in this case, 200, doesn't matter. It's selected in a way that ensures that every different possible sample is possible and is equally likely to happen. Every combination of 100 people, every combination has an equal likely chance of being selected. And that's a simple random sample. So it is possible for all 100 people to be seniors, for example. That is possible in a simple random sample. Not likely, but possible. All right. So it's not always going to be a representative sample, but it typically does a pretty good job. Okay, but there's no guarantee. All right. And another way to do a simple random sample is, let's say we didn't want to write all 2,000 students on slips of paper. That's very time consuming. So instead, we get a roster of all 2,000 students, right? Every single name. That is what's called a sampling frame. If we have a list of all the people in the population, so we have our sampling frame, and we give each student a unique number, like 1 to 2,000. Okay, so 1 to 2,000. So imagine that long list of every single person's name with the numbers 1, 2, 3, 4, all the way up to 2,000. And then we go to our computers and we Google random number generator, like we did with our rectangle activity, and we have it generate 100 unique numbers. And then with that, we look at whose numbers came up, and those are the people in our sample. That's another way to do a simple random sample. Okay, so you just kind of select individuals at random. Okay, a little side note about that. The example that I just gave, I was sampling without replacement, So once I pick somebody's name out of the hat or out of the container or out of the sampling frame, I continue to pick, but I don't put the name back. So a person can't get picked twice. All right, so that's a subtle detail that you want to kind of note when you're explaining how to sample something. Are you doing it with replacement or without replacement? All right, so that's kind of a detail that's nice to say. All right, any questions about simple random sample so far? Okay, so let me go ahead and talk a little bit about this whole sampling with replacement, without replacement, and how it relates to sample size. Now, sampling without replacement versus with replacement can actually be treated as pretty much or practically the same as long as your sample size is less than 10% of the overall population. Less than 10% of the overall population. If you're sampling less than 10% of the overall population, essentially sampling with replacement versus without replacement is practically the same thing. Okay, so to kind of give an example of this, imagine this beautiful scenario with me where we go to San Marino High School and we empty out the pool and we fill the entire pool with Skittles. Okay, so imagine that. The entire pool is full of Skittles. Now we want to, let's say, find a sample to see how many purple Skittles are. That's my favorite Skittle, purple. All right, I want to figure out what percent of the pool is purple Skittles. So what I do is I start sampling. I'm going to sample, let's say, 2 handfuls. Okay, so then I grab a handful or grab one and look, it's a purple, 2, 3, 4, 5. Let's say I'm going to get 20 of them. Whether or not I put the Skittle back into the pool or I leave it out, it really doesn't matter, right? I mean, imagine that entire pool full of Skittles. If I leave 1 or 2 out or even 20 out, it's not going to be a big deal. It's not really going to affect what's happening in the entire pool. All right, so that's kind of the idea of why it doesn't really matter as long as your sample size is less than 10%. Does that make sense? Yeah, kind of. Okay, cool. All right, now speaking of sample size, let me ask you guys a question, and I want you to put your answer in the chat. Okay, so everybody listen to this question so you can put your answers in the chat. San Marino High School, we have about 1,200 people, right? 1,200 students. How many people do you think we would need to sample in order to get a pretty representative sample? Like, how large of a sample should we take? So obviously, like, 1 person is too small of a sample. But do we need like 1,000 people to be a sample to represent the 1,200 students? I don't know. So go ahead and write down a number in the chat. How many people do you think we need to get a representative sample of San Marino High School, of 1,200 students? All right, I got 120, I got 100, 100, 100, 200, 100, 120, 150, ooh, 50 per grade, 60, 120, 120, 100, 100, 150, 200, 250, 200, 25. Oh, all right. Okay, okay. All right, so we got numbers ranging from 25 to, I think the highest one I saw was like 200. All right, so 25 to 200. All right. Oh, 125. Okay. Got it, Alan. All right, so 125 to about 200. All right, that's a pretty good sample size. I think that would actually do a great job to get a sample from San Marino High School. Okay, follow-up question. Let's say we go to Arcadia High School. Okay, so you guys know Arcadia High School. About how many people are at Arcadia High School? Does anybody know?
I think it's like 4,000 because there's like 1,000 per grade.
Okay, yeah, so about 3,500, like 4,000. Yeah, so it's huge. Like their entire marching band is the size of our school. Yeah, so it's a huge school. So, okay, let's say we go to Arcadia High School and we want to get a random sample to represent all 4,000. How many people would we need now to get a good representative sample? Go ahead and put it in the chat box. All right, 400, 800, 400, 400, 500, 500, 240, 400, 400, 400, 401. Evan's playing Price is Right. 500, 400, 500, 400, 500. All right, nice. Yeah, okay. So a lot of you, so the range here was from, let's see, lowest was 240, highest is 800. Now, it's so reasonable, right, that we would need a bigger sample if we have a bigger population like Arcadia High School. But I would say if we can just survey 100 students at San Marino High School and get a good sample, I would actually venture to say that we just need 100 people also to get a good sample at Arcadia High School. So that actually, a lot of people are like, wait a second, it's a much bigger population. Shouldn't we need a bigger sample? Actually, the answer is no. We don't need a bigger sample. It's actually not the size of the population that matters. It's the size of the sample, okay? So it's not like a certain percent we're trying to hit. So let me give you guys an example that makes this, I think, make a lot more sense about why that's true, okay? Because I don't think you guys are convinced. You guys don't look convinced. All right, so let's say, all right, let's say Nick. Let's say Nick's not feeling too well, okay? Pretend you're sick, Nick. Cough, thank you. Okay, so Nick is sick, and I'm like, oh no, Nick is sick. I'm gonna cook him some chicken noodle soup. Okay, so I'm gonna cook him some chicken noodle soup. Wow, that is a huge jug of water. Um, and I cook him a bowl of chicken noodle soup, and I give it to him, and he grabs a spoon and he tries it. Okay, and then Nick, what's your response after trying my soup?
That's good soup.
Hey, good job. All right. See, I didn't even tell him to say that. Good job. Okay. So he gets a spoon, he tries, he's like, oh, that's good soup. Okay. Now, go back. Let's say, though, this time, instead, I didn't give Nick a bowl of chicken noodle soup. Let's say I gave him an entire pot full of chicken noodle soup. All right. So I'm like, oh man, this guy's real sick. He needs a lot of soup. So I give him an entire pot. Does Nick now need to drink an entire ladle full of soup in order to really taste what the soup tastes like? Do you, Nick? Do you need to drink the entire ladle? No, right? You can use the exact same size spoon you did with the bowl of soup. You can use the exact same, and you can still get a good sample. You can still get a good taste of whether or not Nick likes the soup. All right, so that's the idea. You actually do not need a bigger spoon just because you have a bigger population. The key is you just need to make sure you have a big enough spoon, period. Like you wouldn't use like a fourth of a teaspoon to taste test the bowl or the soup or the pot, right? It would be way too small for either of those situations. You just need a large enough spoon, period, and that's your sample size. Also, I'm going to throw this into the same analogy. He has to make sure he mixes the soup first, right? He needs to stir the soup because you know that fat layer that goes on top sometimes, and you got the noodles, you got the chicken, and I don't know what else goes into soup, like celery, I don't know, carrots. But he has to stir, right? He has to stir first and then scoop, and that's the randomization part of sampling. All right, that's the whole, randomization is important to get a good distribution, okay? So hopefully that kind of convinces you guys and makes more sense about why the fraction of the population is not the important part. It actually doesn't matter. It's just the sample size itself that's important. So that's why we can just survey 100, 150 people at San Marino and the same size at Arcadia. Does that make sense? Yeah? Okay, cool. All right, hopefully you guys are convinced. Okay, all right, so going back, sorry, that was more of like a side note to our lesson. We talked about simple random sample. That's number one. Let's talk about our second type of sampling. So we're on the back of your notes right now. All right, so the example is same thing. We have 2,000 students at our school, and we want to get a sample of 100. So instead of just taking a random 100, we take 25 students and randomly pick 25 from each grade level. So 25 freshmen, 25 sophomores, et cetera, et cetera. This is an example of what's called stratified random sampling. Stratified random sampling. All right, so the process for stratified random sampling is first, you break your population into subgroups, okay? Non-overlapping subgroups. And these groups are typically homogeneous, like they're similar to each other. Like seniors are similar to each other, juniors are similar to each other, etc. And then after that, you take a simple random sample from every group. Okay, so some seniors, juniors, sophomores, freshmen. So every single group is touched, and every group you pick randomly from. All right, so here's a picture of kind of what's going on in my mind. Okay, so you got your population, breaking it up into homogeneous groups, and then a simple random sample from each group. All right, so this is stratified. Any questions on our second method of sampling? Okay, so our third method of sampling. This time, okay, instead of breaking them into grades, let's say we just randomly pick second period as the time we can survey, and we randomly pick 5 classrooms and survey everybody in those 5 classrooms. Okay, we survey everybody in those 5 classrooms. This is an example of cluster sampling. Cluster sampling. Now, this can get confused with stratified, and let me tell you why. So in cluster sampling, the first step looks very, very similar to stratified, okay? So the first step is to break your population into non-overlapping subgroups. Looks very similar to stratify. This time though, you want your subgroups to be heterogeneous. So basically every group is almost like a small mini version of the population. You have all sorts of different people in each group. Now, the most obvious distinction from stratify is actually the second step. Instead of picking some from each, you randomly pick a few of these clusters and survey everybody in those randomly picked clusters. So you're not touching every cluster. You randomly pick a few and you survey everybody in those randomly picked clusters. Okay, so picture looks like that. You got your population, divide it up, randomly pick 3 clusters here, and survey all in those 3 clusters. Okay, any questions about cluster sampling? All right, let's try our last one then. Okay, so our last one is called systematic random sampling. Systematic random sampling. This one is where, let's say, we get an entire alphabetical list of all the students. We number them from 1 to 2,000, randomly pick a person to start with, and then choose every 20th person after that original randomly picked student. All right, so that is called systematic. So basically, you will randomly start or pick a random starting point and then go every nth individual or person after that. And that's just systematic, okay? All right, questions on systematic? Okay, so you guys have your 4 different sampling methods, okay? So the first one is a simple random sample. This one, you don't break it into any subgroups. You just have the entire population and you randomly pick individuals. Second one's stratified. Third one is cluster. Fourth one is systematic. Okay, so your goal, guys, and this is how the quiz questions are gonna look, is given an example, determine which sampling method is being used, okay? So let's try an example. Let's see, Andrea, can you read this one out for us?
The Educational Testing Service needed a sample of colleges. ETS first divided all colleges into groups of similar types: small public, small private, medium private, large public, and large private. Then they randomly selected 3 colleges from each group.
Awesome, thank you. Okay, go ahead and write down which of those 4 you think. Simple random, stratified, cluster, or systematic. Okay, and let me go to Megan G. What do you think?
I wasn't done thinking about it, but is it stratified?
Yeah, good job.
Okay,
Why do you think it's
cool.
stratified?
Because they took it into separate groups and then from there did the simple the simple random one.
From each of the groups.
Yeah.
Perfect. Yes, you are absolutely correct. So, stratified random sample, broke it into homogeneous groups, randomly sampled and touched every single one of those groups. Nice. Okay, let's try another one. Okay, this one, let me go ahead and ask Cassidy. Can you read this one out for us?
A country commissioner wants
county.
to survey people.
Oh, county commissioner.
Wants to survey people in her district to determine their opinions on a particular law before adoption.
Mhm.
She decides to randomly select blocks in her district and then survey all who live in those blocks.
Nice. Thank you, Cassidy. Okay, go ahead and write down which of those 4 sampling methods you think. All right, let me go to Evan. Evan, what do you think?
Is it cluster sampling?
Yeah, good. And how did you know it's cluster as opposed to, like, let's say stratified?
Cause on the notes I have an example down and it was said that it was like, oh, one way to do this would be randomly selecting 5 classrooms during a second period and then surveying all the students. And I was like, wait, that kind of sounds like this.
Okay,
So
so
that's
what
kinda
is
how I
kind of
went
like
for
the
it.
one key word that stands out that makes
It's
it?
random. It's the only one that's random in the bunch, right?
No, we use randomization in a lot of them. But in that second step, after you break it up into groups, you survey
All of them, right?
all of them. Yeah, I would say the key word here is all, right? Once you break it up into those blocks, and then you randomly pick 5 of those blocks and survey all in those blocks, right? So you're not touching all the blocks, right? But you survey
Yeah.
all from certain randomly picked blocks. So yeah, cluster, good job. All right, let's go to Aaron. Aaron, can you read this one out for us?
A local restaurant manager wants to survey customers about the service they receive. Each night, the manager randomly chooses a number between 1 and 10. He then gives a survey to that customer and to every 10th customer after them to fill it out before they leave.
Awesome. All right, go ahead and write down which of the 4 methods you think. All right, and let me go to Bella G. What do you think?
I put systematic random sample.
Good, and why? Nice.
Because he first picked a number between 1 and 10, and then every 10th customer he gave the survey to.
Nice, yeah. After that, jumped every 10. So that is systematic. Good job, guys. Well done. Okay, any questions? All right, let me go ahead and have you guys practice this a little bit more. So grab the second handout that says part 2 at the very top. identify the sampling method. And this time they give you 5 options. They give you the simple random, stratify, cluster, systematic, or convenience. So they threw in one of the biased ones to see if you can sniff that one out. Okay, so I'm going to put you guys into breakout rooms and then try these together and we'll see what you get.